001. So welcome and thank you for joining us for our Lunch and Learn that is titled Paved Paradise, the Ecological Impacts of Our Planet's Road Network. I'm Megan Litzy, MECA Board President, and before we want to get started, we wanted to just share just a really brief introduction about what MECA is for those of you who are hearing about us for the first time, and just go over a few housekeeping items before we get started. So for those of you who are hearing about MECA for the first time, MECA is a nonprofit organization that is dedicated to providing educational information and business opportunities for various parties that are involved in the erosion and stormwater management industry. And if you are joining us for this first time for this Lunch and Learn, this is just one example of some of the interesting and unique things that we do as an organization. And on this next slide, I just have a really brief overview of some of our upcoming events for those that might be interested in checking out some of the other things that we have going on throughout the year. And you can find more information about these events and registration information on our website at mnerosion.org. And you can also follow us on social media as well. Just a quick plug for our membership. So for those of you who are members, thank you so much. And if a membership is something that you're considering, it's a great way to have access to these educational opportunities, as well as also have access to discounts for future events as well. So highly encourage you to consider that. And it's a great opportunity to stay connected to the industry. So without further ado, up next, we're going to hear from Ben Goldfarb on today's talk titled Paved Paradise, the Ecological Impacts of Our Planet's Road Network. Ben is an independent conservation journalist and the author of Crossings, How Road Ecology is Shaping the Future of Our Planet, and Eager, the Surprising Secret Life of Beavers and Why They Matter. With that, welcome, Ben.
Thank you so much, Megan, for that introduction. Thanks to all of you for being here. Thanks to MECA for having me. I will share my screen. Fantastic. Can you guys all see that? That looks like a bear crossing a road, right? Cool. So this talk isn't about erosion control or stormwater management per se, but I hope it gives you a different perspective on the role of transportation networks in shaping and altering and really distorting our planet's ecosystems. And the conversation this afternoon that we'll be having and the book that it's based on are about road ecology, which is essentially this relatively small, but I would say very fast-growing field of science that looks at all of the many ways that roads and nature interact, erosion certainly included. And because I know many of you are transportation professionals, some of this is probably familiar to you. But of course, roads are so transformative in large part because there are just so many of them, right? We have something like 4 million miles of road in the United States. Around 40 million miles of road globally, and we're in this period that the ecologist Bill Lawrence has called the infrastructure tsunami, this wave of new construction that's sweeping the planet and will bring something like 15 million miles more of paved roads alone to the planet by 2050. And of course, roads are fundamentally useful. They're how we get to schools and hospitals and grocery stores and so on. They're so ubiquitous, I think, that we don't really notice them or think about them very much. And of course, they also have very powerful cultural connotations in the U.S. They're symbols of freedom and mobility and momentum that Bruce Springsteen sang about and Jack Kerouac wrote about. And I find that freedom and mobility somewhat ironic, because for all of the freedom they're providing human travelers, they're denying in non-human travelers on truly a massive, almost incomprehensible scale. And the way they do that most conspicuously, of course, is by roadkill, by killing animals directly. I know that a lot of you spend a lot of time on roadsides, and so this is, unfortunately, a very familiar sight to you. Often when I give talks in person, I ask the audience how many vertebrate animals, so that's just backboned animals, right? Birds, mammals, reptiles, amphibians, are killed by cars every day in the U.S. And typically the guesses range from 1,000 to 100,000 or so. But in fact, more than 1 million vertebrate animals are killed by cars in the United States daily, which is again to say nothing of insects and arachnids and so on. Probabilistically, of course, most of the animals we see are the relatively common ones, right? The white-tailed deer and the raccoons and the opossums, which I think creates an impression that, roadkill, yes, it's tragic for those individual animals, but isn't necessarily a conservation issue, right? Yes, lots of deer are being hit by cars, but, there are a lot of deer out there. But in fact, there are dozens of federally threatened and endangered species, from ocelots to Florida panthers to tiger salamanders, to wood turtles, for which roadkill is, one of, if not the primary source of mortality, right? So this is a conservation crisis, as well as a kind of an ethical crisis. And in fact, as Richard Foreman, who's one of the founders of road ecology, has put it, roadkill is the leading direct human cause of vertebrate mortality on land, right? Which is just a fancy scientific way of saying that there's literally nothing that we do that kills more wild animals than drive, right? We're in the middle of this 6th mass extinction in our planet's history, and automotive culture is, an enormous contributor to that. I think one of the things that makes roadkill really pernicious and problematic is the way that it basically takes evolution and subverts it or hijacks it, right? If you think about the defense mechanisms of many common animals, they're fundamentally hunker down and stand your ground defense mechanisms. Turtles withdraw into their shells, and porcupines bristle their quills, and skunks spray, right? These are, again, kind of hunker down strategies that worked really well for thousands of generations against wolves and cougars and coyotes and all kinds of natural predators. But when your predator is an F-150, barreling down I-94 at 70 miles an hour, the worst possible thing you can do is withdraw into your shell, right? So roadkill and modernity takes the kind of the history of the evolutionary history of many species and renders it not only moot but actually maladaptive. I find that kind of tragic to contemplate. So road ecology, historically has focused largely on wildlife vehicle collisions, the impact of road mortality on ecosystems. But of course, that's just the tip of the iceberg when it comes to how transportation networks and nature interact. And increasingly, I would say road ecologists are taking this broader, more holistic view of these interactions. Roads are vectors of invasive species. We've all seen, 1 million non-native plants and animals along our roadsides. Here's one example of that. This is an old logging road in Montana, where for many decades, logging trucks transported the seeds of invasive thistles in their tires, and eventually all of those thistles basically bloomed at once after a kind of a big rain event, and now there's this eerie, linear purple stripe of vegetation running across the landscape. I don't have to tell this group, obviously roads are enormous vectors of erosion. I think unbeknownst to the average American is the fact that the single largest road manager on earth is the US Forest Service. There are something like 370,000 miles of Forest Service road out there, to say nothing of tens of thousands of miles, managed by other public agencies, and most of those Forest Service roads, of course, are old dirt logging roads that have long since outlived their original purpose. They're unsurfaced, they don't get much traffic, but they're immense erosion hazards. And in the book, I talk about sort of vast chains of landslides triggered in places like Idaho and Montana and Oregon and Washington by major snow melt events or rainfall events on surfaced logging roads and steep forested areas, which of course again you know all of this, although the average member of the public probably doesn't. But with immense impacts to fish habitat, amphibian habitat, downstream water quality, and so on. Roads are sources of pollution, right? Again, this is familiar, I think, to the stormwater managers in this group. But our vehicles are constantly hemorrhaging cadmium and copper and zinc and microplastics and all kinds of stuff. We're learning more about those chemical interactions all the time. As you may know, a few years ago, a group of scientists at the University of Washington basically looked at many decades of coho salmon die-offs and connected them to 6-ppd, which is a kind of an obscure ozone protecting chemical in tire particles. 6 million tons of tire particles enter the planet's waterways every year and have immense impacts on fish and wildlife. And this is the only place this has been studied is Western Washington, although increasingly other Pacific coastal states are looking at the impacts of tire particles on salmon. But what are tire particles doing to walleye and brook trout and smallmouth bass? And in Minnesota, to my knowledge, nobody's looking at those interactions. But certainly we're learning more constantly about some of the negative chemical interactions that transportation produces with nature. As I'm sure this group knows, one of those primary chemical impacts is road salt. The U.S. adds something like 20 million tons of road salt as a de-icing agent every year. Minnesota, I believe, is the single most profligate user of road salt in the United States. And of course, all of that road salt has to go somewhere. And it ends up in rivers and lakes and streams and wetlands. Something like half of the lakes in the upper Midwest are experiencing long-term salinization, so becoming saltier over time, with immense impacts to amphibians and trout and even zooplankton and other organisms. We're also turning our roads into salt licks, essentially. Animals are attracted to road salt and end up in these very dangerous situations as a result. I will say that the road salt issue inspired my favorite road sign. This is in Jasper National Park every winter in Canada. You can see signs saying, "Do not let moose lick your car." This might be a problem that you're familiar with as Minnesotans. I'm not sure you could stop a moose from licking your car. I think if a moose wants to lick a car, it's probably going to do it. But those are the kinds of strange, novel interactions that road salt can create. Roads are also hellscapes of noise, right? If you're a western meadowlark who has to sing to attract a mate, and your mate can't hear you over the noise of engines and tires, you fundamentally can't live in that place, right? Road noise is an enormous form of habitat loss, effectively. A road might only be 150 feet wide from shoulder to shoulder, and yet the acoustic shadow or envelope that it can create, can span a mile or more. And of course, road noise is also an immense impact on human health, that elevates our cortisol levels and blood pressures and risks of stroke and cardiac disease and other maladies. It's collectively taking many millions of years off of our lives. It's one of the great unsung public health crises, I think, of modernity. Here's just one quick video that I think illustrates this concept of road noise as habitat loss, because it's not super intuitive to everybody. Hopefully you can all see and hear this video. These are some brown bears somewhere on the Pacific coast doing their thing. And then that ATV engine noise comes in and immediately those bears flee the area, right? So again, road noise is habitat loss. I think that's an important concept. But it's not all doom and gloom, right? I mean, yes, transportation networks are destroying ecosystems or altering them, but they're also creating ecosystems on truly a massive scale. Animals are endlessly flexible and creative and adaptive and really good at taking advantage of the concrete habitats that we've created for them. When I was in Minnesota a few years ago, a MnDOT biologist took me to a highway overpass, a bridge, and on the underside of the bridge there were these, these little concrete crevices, and there were hundreds of little brown bats roosting in those crevices, right, taking advantage of a novel ecosystem that our infrastructure had created. Of course, another example of roads as habitat that you're all familiar with are roadsides, right? In places like Minnesota and Iowa and Illinois and Kansas, roadsides are some of the best available remaining strips of native prairie in landscapes that are otherwise corn and soy and lawn monoculture, and lots of organisms from monarch butterflies to rusty patch bumblebees, take advantage of those habitats. This is a dynamic that, I'm sure you've all seen as people who spend a lot of time in and around verges. And so there's, an immense potential habitat benefit there, right? Roadsides, again, are the largest form of public land in many states. But they're also dangerous habitats. I think that's an important thing that road managers have to consider is to what extent are we producing organisms, on roadsides, and to what extent are we creating ecological traps potentially, luring animals in with the promise of resources, and then, and then potentially killing them. Monarch butterflies are kind of the classic example of this. There are hundreds of millions of milkweed stems, along interstate highways in the Midwest. But millions of monarch butterflies are also killed by cars during their migration. We don't really think about insects as being roadkill, but this is one of the primary sources of mortality for monarch butterflies. Not to mention all of the sublethal effects that come with with feeding on plants that are exposed to various chemical pollutants associated with transportation, right? So again, I'm not saying that that roadsides are bad habitat or are ecological traps, merely that I think it's an important thing that road managers need to consider. How do we manage these habitats to maximize their benefits and minimize their dangers? And I bet there are people in this group who are thinking about that very question. Certainly, there are researchers at the University of Minnesota who are studying that issue. Another example of the road as a dangerous resource is with scavengers, right? We've turned our highways into these linear carcass trails that end up, being really, really good potential foraging grounds for bald eagles and golden eagles and ravens and magpies and coyotes, right? We've all seen this dynamic. And here in the American West where I live, golden eagles, animals that are sort of that whose prey is basically under snow in winter, are really reliant on winter kill of deer and elk and pronghorn for their survival. And so roadkill is a big potential resource for them. But it's also obviously, again, a dangerous resource, right? If you're an eagle with a belly full of venison, it takes you a minute to achieve liftoff. And in fact, thousands of eagles are killed by cars every year. Again, not an organism that we really think of as being susceptible to road mortality, but it's a huge impact on golden eagles in particular. And there's actually a great study by a group called Hawkwatch in Utah, who basically found that if road maintenance crews took those roadside carcasses and just dragged them 40 feet off the shoulder, you'd be creating essentially a safe resource for eagles to feed upon without running the risk of being hit by cars or having to flush repeatedly whenever traffic goes by. So there are ways of taking this kind of unfortunate incident of roadkill and making it a more productive, viable benefit for wildlife. And of course, it's not just animals themselves who suffer in these negative interactions between cars and wildlife, these wildlife vehicle collisions. Obviously, collisions are also really dangerous to us drivers, right? There are something like 2 million or up to 2 million large animal collisions in the United States every year. So that's about a collision every 30 seconds, I think. So many collisions during the course of this conversation. These days, the average deer collision costs society more than $9,000 in hospital bills and vehicle repairs and insurance costs and so on. Large animal collisions of all types cost the United States more than $10 billion annually, billion with a B. And of course, it's not just deer that are roaming around out there. The average moose collision costs society more than $40,000. And more than 400 drivers are killed in deer collisions annually, which makes white-tailed deer the single most dangerous wild animal in the United States. Which I think, of course, is not the deer's fault, right? It's sort of automobility's fault, but is, I think, an amazing indicator of just how frequent and problematic these incidents are. And I've talked to state troopers who I think that's a dramatic underestimate, right? Lots of fatal single car crashes where somebody hits a telephone pole or a tree are likely events in which drivers were swerving to avoid an animal on the road and unfortunately didn't survive to describe the incident. So just to say that all of these statistics about the frequency and the cost and the danger of large animal collisions are dramatic underestimates because most incidents don't get reported or recorded in any way. So historically, the way that transportation departments have attempted to mitigate these sorts of incidents is with this thing, right? The deer crossing sign, which you've all seen a million times. And I'll just tell you empirically what, I bet you've deduced intuitively, which is that these things really don't work, right? Transportation departments, and I'm sure there are, people from MnDOT here today, so, no disrespect. But, I would say that most state agencies don't put these things up in any kind of systematic, structured way. They're just kind of present willy-nilly on the landscape. Often you see this sort of thing, deer crossing next 30 miles. But obviously no driver is going to remain totally alert with her foot on the brake for 30 miles. And because these signs are so ubiquitous on our roadsides, I think that most drivers tend to habituate to them and ignore them and tune them out. And I've heard, various state DOT folks in various states describe signs as litter on sticks, which I think gets at their uselessness nicely. So if there are sign defenders out there, feel free to comment. But my impression from talking to road ecologists and reading the literature is that it's pretty clear that conventional animal warning signs are not helpful. And I think it's important to point out as well that even if roadside signs were effective in reducing collisions, from the animal's perspective, the collision is only part of the problem that roads create. And for many wildlife populations, I would say the bigger problem isn't collisions per se, it's actually the loss of animal mobility and habitat connectivity that comes with traffic, right? If you picture, a busy highway like I-90 or I-94, that constant flow of traffic is effectively, as some biologists have put it, a moving fence, right? This total obstacle or barrier that prevents animals from even attempting to cross the highway. And again, for some populations, I think that's actually more problematic than roadkill. And one of the places that I went in working on this book that I think illustrates that point is southwestern Wyoming. There's a very famous herd of migratory deer, mule deer, who live in a place called the Red Desert, who walk 300 miles round trip between their summer habitat and their winter habitat. And researchers have put satellite collars on them and you have a very good sense of where they go and where they like to hang out. And what those scientists have discovered, not surprisingly, is that those animals never cross the interstate highway, right? I-80, which runs through the southern part of their winter range. And that's problematic because all of the really good winter habitat, that kind of nutritious, snow-free grass and low elevation valleys, is south of the highway, right? So during those harsh winters, those deer will basically pool up on the north side of the highway, looking for a gap in traffic that they can run through to access that good winter range to the south and never finding one, because that interstate gets something like 15,000 vehicles per day, which actually isn't a huge number compared to many interstate highways. So during especially harsh winters, 40% of that herd will actually starve because they can't find that good winter habitat, right? And again, I think that's probably worse than roadkill. A herd of 1,000 deer can handle a few collisions on the highway and survive. What they can't handle is mass starvation, because they're losing access to all of that good habitat. So that habitat fragmentation problem that traffic poses or imposes, I think, is almost worse than roadkill. Here's another illustrative map. These are the movements of a single young male grizzly bear in Montana. That white line is I-90, and every red X is a place where that bear basically approached the highway and bounced off like a ping pong ball, repelled by that constant flow of traffic. And this bear attempted more than 40 crossings before he finally found his way across the highway after about 6 months of trying, right? So from that bear's perspective, again, that interstate is 200 feet wide from shoulder to shoulder, but it's denying him access to hundreds of thousands of acres of habitat. And certainly I think that Minnesota's black bears are a little bit more road savvy than grizzlies, a little bit more road tolerant and probably better at crossing in some respects. But you could see this the same sort of map certainly with many of your own fauna. Here's another depressing map. I kind of love these things. These are mountain lion locations for cougars just west of Los Angeles, a very famous population of mountain lions in the southern Santa Monica Mountains. Each sort of cluster of different colored dots, of course, is one individual collared mountain lion. Those red lines are the freeways, right? The 101, the 405, the busiest freeways on Earth. And what you can see very clearly is that those animals never cross those freeways, right? Those freeways are total barriers to mountain lion movement. And as a result, those cats in the southern Santa Monicas are basically cut off from mountain lions elsewhere in California. They're stuck mating with their own daughters and granddaughters and great-granddaughters. They've become very inbred over time and have begun to suffer genetic defects. And they've entered what some researchers have called an extinction vortex, this kind of long-term doom spiral inflicted by the habitat fragmentation that highways cause. So we've got these two linked problems, right? We have these wildlife vehicle collisions that are very dangerous for drivers and animals alike, and are driving some species to extinction, and are also huge human safety risks. And we've got this habitat fragmentation problem, right? The fact that these barriers of traffic are basically preventing wildlife from navigating the landscape. So how do we solve these two linked or related problems? And really the best solution at our disposal are wildlife crossings, right? Overpasses, underpasses, culverts, tunnels, various structures that animals safely use to safely navigate highways. So this idea of building dedicated infrastructure for wildlife really began in Western Europe in the 1950s. France was the first country to build wildlife crossings, followed by Germany and Switzerland and Austria. Today, the Netherlands is probably the best at this. Certainly, they have the highest density of wildlife crossings of any country. Obviously, the Dutch are just great engineers at everything they do. Here's a famous Dutch overpass that crosses 2 lanes of traffic, a railroad, a bike path, a sports complex, and a business park, right? A kilometer-long overpass, pretty cool structure. The place that wildlife crossings really became renowned or famous or accepted as a viable technology for transportation agencies was in Canada, in Banff National Park, very famous wildlife crossings. The first were built in the 1980s. Parks Canada built a series of underpasses for elk and deer primarily. And then in the 1990s, followed up with a series of overpasses, which are really intended primarily for grizzly bears. Not surprisingly, some animals are willing to go under highways, like black bears, which are kind of forest dwellers who are fairly comfortable in enclosed spaces, whereas grizzly bears, are kind of evolved on the Western plains. They're animals who prefer to be out in the open, where they can confront their foes, their enemies. And so, they'd rather be up on the deck of a bridge than, going through a box culvert. So those overpasses were really built primarily for grizzly bears, which took a few years, but eventually began to use them. Went back and forth, mated on both sides. The sows would teach their cubs to cross, their cubs would teach their cubs, and so there was kind of this cool intergenerational learning process that happened around these wildlife overpasses in Banff National Park, and essentially this 20-year research program, which is still ongoing, showed very clearly that these overpasses were successfully healing the genetic divides that the Trans-Canada Highway had inflicted on that population. That bears really were mating on both sides of that highway and exchanging genes. So those Banff crossings and the research that emerged from them, I think, really helped this concept or technology become widely accepted among transportation agencies. Here in the U.S., the first wildlife crossings were built in the 1970s primarily for migratory western ungulates, for mule deer, elk, antelope. And the reason for that, is that, again, in the American West, in states like Colorado, where I live, we tend to have very migratory animals. It's sort of this harsh mountainous environment where animals have to move in large numbers. Between pockets of seasonal resources. And if you get, 1,000 mule deer all migrating together, crossing the same highway in Wyoming year after year, in the same place, there's pretty quickly this big pile of carcasses saying, hey, put a wildlife crossing right here, right? So those Western migratory ungulates in states like Utah, Wyoming, Colorado, those were really the first animals that, that American transportation agencies mitigated for. I would say that that Eastern and Midwestern states historically have basically said, or historically did say, that well, fine, okay, wildlife crossings work for those Western guys who have the migratory wildlife, but here there are just kind of white-tailed deer everywhere all the time, right? There aren't discrete migratory pathways or discrete hotspots of roadkill that we can mitigate. So Midwestern and Eastern transportation departments haven't really historically embraced this concept, but that's really starting to change over the last 5 years or so, and we'll talk about that in a second. But just suffice to say, for now, historically, this is something that Western states did that east of the Mississippi you didn't see a whole lot of for a long time. An important lesson that road ecologists learned very quickly was the importance of fencing, right? People always ask, how do the animals know to use the wildlife crossings? And, the obvious answer is that the fences make them, right? You fence off that roadside, and basically guide the animals to the crossings. A deer is trying to find a spot to cross, hits that fence line, paces the fence line for a quarter mile, and then there's the box culvert, basically beckoning to them. So those two elements, the crossings and the fences, really go hand in hand, right? It's the fences that are preventing the roadkill, keeping the animals off the highway, guiding them to the crossings, and the crossings that are encouraging that habitat connectivity and allowing these animal movements to continue. I'd say, another important lesson that transportation agencies have assimilated over the years is the importance of providing a diversity of crossing opportunities, right? We know that every species, has its own ecological niche, its own habitat requirements, and likewise, every species has its own wildlife crossing requirements, right? Here in Colorado, we've got mule deer who are very happy going under highways via box culverts, and we've got pronghorn antelope, who will basically only use an overpass, right? So providing crossing opportunities for the entire suite of species you're trying to help, is really important. Here's one example of that. This is a wildlife overpass in Washington on I-90, just east of Seattle, very famous project on Snoqualmie Pass. And the overpass is primarily for elk, who tend to be overcrossers. But, they've also got fence lizards and western toads and all kinds of rodents in that system who were also divided by that highway. So they bolted in all of these log structures, which I've heard some people call faunal furniture, to basically provide these micro habitat elements that allow animals, smaller animals, to safely cross that highway. Here's another nice wildlife crossing from that same project, I-90 in Washington State. Just a beautiful kind of big, capacious underpass where they actually twinned the highway, right, to allow light to hit the forest or the underpass floor and just create a more welcoming, inviting, natural seeming vibe for those critters. You can also see in the back of this underpass this line of rocks that runs through the wildlife crossing, and that's primarily for pikas. Pikas are small rabbit relatives who live in talus slopes in the American West, and so you've got this kind of artificial talus slope running through the underpass, providing pika connectivity, right? So I think it's a cool example of thinking about the entire system. Another nice crossing from that same stretch of highway. This is just a beautiful spot where they really opened up that floodplain, right? So this little creek, which had been funneled through kind of a narrow culvert, they essentially tore that out and elevated the highway for something like a quarter mile, and provides floodplain connectivity, and also just lets that stream be a stream, right? And that stream actually has a salmon run in it. So now so you're providing terrestrial connectivity on the floodplain for bears and deer and even wolverines up there and all kinds of cool animals. And then you've got a stream basically facilitating this salmon migration. So a neat example of combining terrestrial and aquatic connectivity. I think it's just one other nice example of that. Another kind of enlarged culvert where they basically tore out, a narrow corrugated metal pipe and put in an expanded box culvert, which provides pretty good connectivity for beavers and otters and salamanders and all kinds of critters. And here's just one quick video that is fun to watch, illustrating how effective these crossings are. So these are all in Washington State, the same project on I-90. The mountain lion, it's cool to see. An elk, cow, and calf, right? Always great to see the the kind of that demographic connectivity, right? The females and offspring using these crossings. That's really important. Coyote. There's a family of otters using one of those culverts there, one of those expanded riparian crossings. Pretty cool. So those culverts, I think, are interesting to think and talk about in a wildlife connectivity context. And as folks who work in water management and erosion control, I know you guys think about culverts. But I'd say that the culverts are relatively invisible to the average member of the American public, and historically, I don't think there's something that agencies have thought much about in a habitat connectivity context either. But there's a fantastic opportunity there, right? We've got something like 2,000 dedicated wildlife crossing structures in the U.S. and something like 2 million culverts. And of course, those culverts are there to convey water, but animals are really good at finding and using and taking advantage of them. And there are things we can do to make those culverts more functional as wildlife passage, right? So here's one neat example of that. This is a culvert under Highway 93 in Montana, north of Missoula. And this culvert gets used by bobcats and weasels and skunks and all kinds of kind of small and mid-sized mammals. But in spring, the water comes up, the culvert is partially flooded, and those critters stop using it because they don't want to get their paws wet. But what what MDOT did in this case was they basically installed what's sometimes called a critter shelf, that metal catwalk that runs through the culvert and provides an elevated crossing opportunity, even when there's a few inches of standing water in the bottom of the culvert. Right. So not every wildlife crossing project has to be, a multi-million-dollar bridge over an interstate highway. Right. There's a lot we can do with the existing infrastructure that's already on the landscape, via cheap tweaks and retrofits. Here's another nice example of that. This is a culvert under I-64 in Virginia, and I said earlier that historically Midwestern and Eastern states have not done as much for wildlife crossings as Western states have, but that's starting to change, and this is one of the projects that's changing that. So this is again a culvert that was not built for wildlife; it was built for the seasonal conveyance of water and livestock. But what the Virginia Department of Transportation realized a few years ago is that, hey, if we just fence off the roadside next to that culvert, we can basically force animals to use it, right? We can funnel deer and bears and foxes and all kinds of critters to that culvert and make a passage for water, a passage for wildlife. And so that's what they did. They fenced off a couple of miles of highway on either side of these culverts. They saw more than a 90% reduction in deer collisions, which is a very typical number with wildlife crossing projects. You're generally seeing at least an 80% reduction in roadkill and often close to 100. I saw a fourfold increase in deer usage, right? So again, you're just guiding animals to that crossing and making them use it. You're turning it into a functional wildlife passage. And most relevant to the agency is that they recouped the costs of that project in under 2 years, right? We talked earlier about how dangerous and expensive large animal collisions are. Well, if you install infrastructure that prevents dozens of collisions a year, as many of these projects do, you can save the public a lot of money very quickly, right? And I think that's a really important point about wildlife crossing projects generally, is that they're good fiscal investments, right? There's always a bit of sticker shock with wildlife crossing projects. These days with inflation and rising construction costs that you're all up against right now. I'm sure the price tag for these projects has gone up. These days, for an underpass, you're starting at $1 to $2 million, and with an overpass, you're probably looking at 8 to 10 million. But because these projects are so good at preventing collisions and improving driver safety, they tend to pay for themselves pretty rapidly. Here's an overpass on Highway 9 here in Colorado, not too far from where I live, that was installed on some mule deer and elk winter range, and paid for itself in under 5 years. Right, this was, I think, something like a $5 million structure, part of this broader network of underpasses and overpasses that in under a decade has already essentially recouped its own cost. So we know that wildlife crossings work from a conservation perspective and a driver safety perspective. They also work pretty well from a cost-benefit analysis perspective. Of course, the caveat to that is that if you take an entirely cost-benefit focused approach for the spots you choose to mitigate, there are a lot of species you tend to leave out, right? And that's what's happened in the US generally, I would say, is that, we've built, certainly not nearly enough, but, a decent number of wildlife crossings for deer and moose and elk and other large animals. But, nobody's ever totaled their car hitting a northern red-legged frog or a garter snake, right? Or a spotted salamander. And so, those smaller animals tend to get ignored, and that's problematic because we know that amphibians in particular are some of the most road endangered organisms on Earth. Right, these are animals who are migrating themselves between their upland forest habitat and their wetland breeding habitat, and you've got roads severing those two habitats. And on those warm, wet spring nights that you're all familiar with, you get thousands of amphibians crossing roadways, and they get squashed en masse. And there's lots of research showing that many amphibian populations are existentially threatened by roads. but we haven't done a whole lot for them because, again, I think the transportation agencies, understandably, are taking this this driver safety and cost benefit focused approach to mitigation. So, certainly we need more large animal passages. That's great. But, we also need to integrate small animal passage and create standalone small animal passages as well. And again, not to say we haven't done that at all. Here's a nice underpass for spotted salamanders and wood frogs and other critters in Vermont that gets used by thousands of migrating amphibians, as well as bobcats and other critters every year. I believe that Minnesota has a couple of turtle crossings. Maybe Washington County has a turtle underpass. I'm sure there's somebody on this call who knows a lot more about that project than I do. So, these sorts of reptile and amphibian and small mammal crossings do exist. We just need a lot more of them. And I'd say that there are countries out there that do more of this than we do. Arguably, this is a very famous overpass on Christmas Island in the South Pacific. And Christmas Island has a very famous migration of red crabs who move from their upland rainforest habitat to their ocean spawning habitat, right? So just like amphibians, they're undertaking these upland to wetland, habitat migrations, and there are a series of these, cool steel overpasses for them that get used by millions of crabs every year. So that's the kind of innovative small animal passage you see in other places. Another neat thing you see in many countries are canopy crossings. We've got all of these arboreal animals, primates and squirrel gliders and sloths in other countries that whose habitats are fragmented by roads, but are not going to descend to the forest floor to use a conventional underpass. You have to reconnect those habitats at the level of the treetops, via these canopy crossings, which work really well. Lots of great research, showing the efficacy of these things. And look, here in the U.S., right, we've got arboreal animals too. In Minnesota, you've got all kinds of boreal forest critters, like porcupines and and various flying squirrels, who are also, again, kind of fragmented and divided, and who would benefit from from canopy crossings. But we haven't done that sort of thing, again, because I think we tend to take more of a driver safety focused approach rather than a conservation approach to some of these projects. And I think there's a lot we can we can learn from other countries and their approach to wildlife mitigation. One of the places I went in working on this book was Brazil. Brazil is a country that's developing its infrastructure very rapidly, right? Building new highways and paving existing dirt highways all the time, including lots of wildlife crossings with those projects. And, one of the neat legal innovations in Brazil is that road operators are actually held responsible for animal collisions, right? If you hit, a tapir or a capybara in Brazil, most of the highways there are actually operated by private toll companies, and you can sue the toll company for damages on the grounds that hey, they should have installed fencing and wildlife crossings, right? We know how to prevent these problems. It's the responsibility of the of the road operator to prevent them. And I'm sure that there are MnDOT folks out there who are cringing at that possibility, but I do think that's an interesting way of turning the problem on its head, right? It's not necessarily the fault of the driver, when these collisions happen, nor is it, some uncontrollable act of God. It's, fundamentally an infrastructure failure that we know how to correct. Another, neat, innovative place is India. India, again, another country that's building out its infrastructure very rapidly, including through some areas of intact habitat, which is, not what you want, obviously. But, there in certain stretches of highway, they've basically elevated the highway on concrete pillars for many miles in either direction. I think up to 10 miles or so in some areas, so that instead of having isolated underpasses, the entire forest floor is basically open for tigers and elephants and other critters to wander back and forth. And I think that doing that increased the construction costs something like sixfold, right? So again, not exactly a thing that many American transportation agencies would be eager to take on. But you can see this sort of thing on a smaller scale in Florida. North Carolina is planning some underpasses for red wolves right now that will involve elevating a section of Highway 64 to some extent. Of course, we do this sort of thing, going through wetlands all the time, right? So, this is the kind of thing that's theoretically possible. Happily, we are in this kind of exciting time here in the U.S. for wildlife crossing construction. As many of you, I'm sure, know, the 2021 Infrastructure Act included the $350 million wildlife crossings pilot program, which is basically a competitive grant program that gives money to states and tribes and other entities for wildlife crossing planning and construction. Around 2/3 of that money has already been allocated, but there's another round of applications upcoming in 2025. Hopefully, obviously, executive order from the Trump administration froze the disbursement of Infrastructure Act funding. A lot of the grants that were already earmarked, are sort of on hold right now as states wait to figure out what's going to happen to that funding. So, this really, I would say, wonderful program is kind of up in the air right now. Hopefully, the projects that the federal government has already committed to funding will actually get funded, and hopefully this program, which really does have bipartisan support, will be reauthorized in the 2026 Surface Transportation Bill. So, the fate of this federal funding is, very much up in the air right now. But, I think that there's some reason to be optimistic that this program is going to move forward. I'll also mention, of course, again, that fish need safe passage as well, right? And in fact, the Infrastructure Act included $1 billion for anadromous fish passage in the form of expanded culverts and the like. And unfortunately, again, I think that program is only for coastal states, but certainly many thousands and thousands of culverts, in the Great Lakes region that also require upgrading for the sake of fish passage. And I'm sure there are people on this call who are working on that as well. But, just to reiterate that obviously wildlife passage and connectivity is not just a terrestrial issue, it's also a really important aquatic issue as well. So, ultimately, the opportunity before us and the challenge before us is to, remake our infrastructure to save biodiversity, right? No pressure, no big deal. But, again, as I said at the start of this conversation, we know that, again, we're in the middle of this 6th mass extinction event in our planet's history, this immense biodiversity crisis, and roads are one of, if not the leading cause of that, right? Remember, there's literally nothing that we do that directly kills more wild animals than drive. And if we fail to deal with the repercussions of traffic, we're going to lose species on a mass scale. Here's an example of that. This is an underpass for ocelots in South Texas. There are around 100 ocelots left in Texas and in the US, and car collisions are 40% of ocelot mortality, right? That's a species that we're losing right now, very much in our lifetimes, because we are not successfully giving it enough opportunities to safely cross roads, right? So, and of course, I'll mention as well that confronting our infrastructure is also immensely important for human safety and well-being and flourishing. We too are roadkill, right? 40,000 Americans killed in traffic incidents every year. Obviously, we talked a little bit about the noise pollution impacts on public health to go along with air pollution, and the community impacts of our highways. So many major urban freeways were constructed in the 1950s and 60s and 70s very deliberately plowing through communities of color in places like Syracuse, New York, where the elevated viaduct of I-81 was basically routed very intentionally through the city's largest Black community. And today, Syracuse is one of the most segregated cities in the country as a result of that, because that physical barrier of the highway disconnects Black and white communities. Happily, this highway, this viaduct, is coming down, or at least it's supposed to come down. This is another example of a worthy project whose funding is in question right now. But basically, the city, the state, with US DOT support, plans to basically tear down this viaduct and replace it with an at-grade boulevard with housing and small businesses and other community elements, right? So it's possible to undo the historic infrastructural mistakes that we made in the 20th century. These mistakes don't have to be permanent, and I think that's an exciting thing to contemplate, in the context of the Twin Cities as well, and in I-94. So if this conversation, merely whet your appetite for, more road ecology discussion, as Megan mentioned, I do have a newish book out on the subject. Both the New York Times and the Wall Street Journal loved it. So there's, liberals and conservatives united around the relatively niche cause of habitat connectivity. And, I say that somewhat facetiously, but, truly, it's one of the few, I would say, absolutely bipartisan environmental issues out there, right? 85% of residents of Colorado, where I live, support more wildlife crossing infrastructure. And, you couldn't get 85% of Coloradans to agree that the sky is blue, right? And yet this is a topic that really has immense bipartisan support in our hyper-polarized society, which I find really exciting. So with that, I'll say thank you all so much for being here. Thanks again to MECA for inviting me. There's my email address if anybody ever wants to get in touch about any of these topics. And I think we've got a few minutes for questions if there are any. So I'll stop sharing and happy to chat for a few.
Perfect. And if anybody is too shy or can't find the mute button, you're welcome to add something to the chat as well.
Cool. Maybe that was just so comprehensive that it answered every possible question.
Absolutely. Well, seeing that we don't have anything coming in the chat, I guess thank you so much, Ben, for your time. That was really insightful presentation, and definitely feeling a little optimistic about some things that we all can do to help protect our road ecology in the future. So again, thank you, Ben, for being with us today. And thank you all for joining us, and have a wonderful rest of your afternoon. Thank you all.
All right. Thanks, y'all.